Okay, so here is a word problem. The Uber driver charges you $5 just to pick you up. Then you need to pay him $2 for every mile to your destination. How much will you pay for your ride? Does everybody see the rate in this problem? $2 for every mile is the rate, right? Because it's happening over and over again. For the first mile, you pay $2. For the next mile, you pay $2. For the mile after that, $2. So we need to define some variables, X and Y. And remember, every or per or each is what's going to separate the X and the Y. So the X and the Y. The units of X are going to be after the every or the per or the each, and the units of Y are going to be before it. Okay. Also, they asked how much will you pay for the ride? So the question that we need to answer is the outcome, which is Y. So this, Y is the money paid for the ride, and X is the number of miles, because how much money you have to pay depends on how many miles he drives you, right? So if he drives you 0 miles, if you call him and he comes and then you say, never mind, you're going to still pay $5, right? Because that's the pickup fee. For 1 mile, he's going to charge you $2 for that 1 mile. So you'll pay $7 for that trip. 2 miles, another $2. So that's 9. 3 miles, another $2. So that's 11. Everybody following this okay? So the expression for 0 miles, the expression was just a 5. There was no math there. For 1 mile, it was 5 plus 1 group of 2, this group of 2 right here. You paid $2 for the 1 mile. I could even say 1 group of 2. For 2 miles, there's this group of 2 and another group of 2. So 2 groups of 2, plus that $5. For 3 miles, there's that $5 that we start with. And then we have 3 groups of 2 that we have to pay for the distance we travel. So if it's X miles, we'd pay Y dollars. And to figure out Y, we would have to do the same math we were doing up here. That $5 up front plus, look at every single one of these is a certain number of groups of 2. And the groups of 2 are the same as the number of miles. For 1 mile, 1 group of 2. For 2 miles, 2 groups of 2. For 3 miles, 3 groups of 2. For X miles, X groups of 2. So that is our equation. Y equals 5 plus 2X. And we can graph that equation. We'll label our axes here. So X is miles. Y is money paid. Let's see, I've got 0, 1, 2, 3 miles. And it looks like I have to go up to 11. I can just count by ones. You know what? I'm going to count by ones for everything. That'll make our life easier later. So I'll call this 1, 2, 3, 4, 5, 5, 6. And I'll count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So when X is 0, Y is 5. Let's get a new color. When X is 0, Y is 5. So that's this point right here, 0, 5. When X is 1, Y is 7. That's this point right here, 1, 7. When X is 2, Y is 9. That's this point here, 2, 9. And then 3, 11. So 3, 11. And then I can draw a line through all these beautiful points. And I have graphed this situation. The situation with the Uber driver and how many miles you're driving and how much money you have to pay. And I know that this line has this equation. Y equals 5 plus 2x. These go together. Okay. So I'm going to reset a little bit. I'm going to take all this away. What if I didn't know the story? What if all I had was the graph? If all I had was the graph, oh dear. If all I had was the graph and no story, does everybody agree I could still find the slope of this graph because we know how to find slope from a graph? So I'm just going to pick 2 points. These 2 points look good. This one and this one. I got 2 points. And I'm going to find the slope by doing the rise over the run. So if I start at this lower point, this point is 1,7. And I go straight up. That's my rise of +2. And then if I head back to my line, I will end up at the point 2,9. And the run is going to be 1. So the slope of this graphed line right here is the change in y over the change in x. Change in y is 2, change in x is 1. So the slope is 2, right? What about the y-intercept? Well, to find the y-intercept, I'm just going to drag my finger down the y-axis until I hit my graph. And the y-axis right here, or the number on the y-axis is 5. So my y-intercept is equal to 0, 5. Look at the slope, look at the y-intercept, and look at the equation that we started with. The equation we made from the story, the equation that we used to graph the graph we just used. Do you notice how this number right here, the number that was the same over and over again in every expression, we call it a constant term? Constant term, because this term does not get any bigger or smaller, no matter what happens to the number of miles. That is the y-intercept. Yeah. And then notice this, the slope that we calculated is here in the equation. It is multiplied times x. This is called, we have a general form for this, and we usually put the mx first. Y equals mx plus b is called the slope intercept form of a line. It's a shortcut. I don't have to make tables. I can just know that the rate and the slope are the same thing. The rate in the story was $2 per mile. The slope in your graph is 2. The rate and the slope will always be the same thing. And they will always be multiplied times x. The y-intercept in the story was that upfront money I had to spend. The y-intercept in the graph is where the graph crosses the y-axis. That is going to be my constant term in my equation. So in this slope-intercept form of a line, m is equal to the slope, and b, whoops, not b, not y, b is equal to the y-intercept. We're going to use this a lot for a lot of different things. Y equals mx plus b. But I'm going to use it right now to find the equation of this line. If I can find the slope of this line, and I can find the y-intercept of this line, I can use y equals mx plus b to find the equation of this line, right? All I need to know is what's the slope and what is the y-intercept. Okay. For the y-intercept, I'm just going to drag my finger down the y-axis until I hit my graph. Boom, that's my y-intercept right there. So the y-intercept is 0 for x, and it looks like 1, 2, 3 for y. Now in y equals mx plus b, b is just the 3, because we're not going to put 0, 3 in an equation. So b is just the y coordinate of the y-intercept. So for this equation, b is going to be 3, because that is the y-intercept of the graph. All right, the slope. I've got this point. I might as well use it, 0, 3. I'm going to come down here and find another good point right here at 4, 1. And then I'm going to find the slope. This time I'm going to use a table because I used the graph last time. All right, so I got x, I got y, 0, 3 is 1 point, 4, 1 is a second point. From 3 to 1, that's an increase of 2. End minus start is, negative 2. Whoops, negative 2, because I am decreasing, right? 1 is smaller than 3. I ended up with a smaller number, so it's a loss. So the change in y is negative 2. For the change in x, from 0 to 4, that's an increase of 4. And I can do the math if you want, and minus start, but I think you all know, if I start with nothing and I end up at 4, that's an increase of 4. And to find the slope, I need the change in y, which is negative 2, divided by the change in x, which is 4. And then I'm going to simplify that. And there's the slope, negative 1/2. Now I can take this m and this b and substitute it into this equation. I'm going to leave the y. I need an x and a y. But instead of m, I'm going to put what m is equal to. So I get negative 1/2. M is multiplied times x, which means that negative 1/2 is going to be multiplied times x, right? I'm just using this as a formula. The only thing I'm changing is m, and I'm replacing it with the slope of this line, negative 1/2. And then b is the y-intercept. We found out that the y-intercept was 3. So I can replace b in this formula with the number 3. And right there, y equals negative 1/2 x plus 3. That is the equation of this line. See how nice that is? So if I give you a graph using y equals mx plus b, as long as you can find the slope and the y-intercept, which hopefully you're getting very good at, you can tell me the equation of the line.